Group 6 auction system presentation. So for the agenda, we'll go over design, user story walkthrough, data persistence, time management, and then all of the user stories. So for the first section, design, our project was designed with the model view controller architecture in mind. We started by looking at the user stories needed to complete Sprint 1 and planning them out on paper. We then looked at the functionality of the system must-have, and then formulated the classes and methods that might handle this. In any software system, it's important to think about how it may be extended in the future, and we kept this in mind to reduce the amount of rewriting we would have to do later on. At the end of the session, we had an actionable plan to work on the auction system, starting with establishing a well-set-up GitHub repo and a rough class diagram. For code management, we know we needed a version control system, so in GitHub we dedicated our master branch to the production-ready tested code. Our development branch is designed to be the merge point for any code that either hadn't been tested with that or of the main branch, or anything we weren't certain of yet. From there, we would each have our own branches labeled by our last name, where we would do all of our individual work. With this setup, we could write code individually, merge it with a development branch, and then finally merge it with the main branch. All of these actions were done with the help of GitHub issues corresponding to a user story. And when commits were pushed to GitHub, the message names included a summary of the work being done, along with an action item like change, add, delete, or whatever else we did. Our README file contains instructions for the workflow and information on setting up code in the IDE. For the class diagrams, these are obviously important for designing software as they provide a graphical relationship between objects. The diagram below is organized into 3 tiers based on the MVC framework. The top is the views, the controllers are in the middle, and the models are on the bottom. The auction report class doesn't fit into these, so it acts as an intermediary between the model and the controller, the view and the controller layers, and it's just there to generate reports for display. This diagram shows the models we use and how they interact with each other.
This is agenda number 2, where we're going to be walking through a user story, and the user story that me and the team has decided to walk through is user story 7, which is the bid on item user story, where the bidder is the actor. And the goal of this user story is to place a bid on an item for a chance to acquire it. So let's walk through the code of how this works. So the interaction begins when the user clicks the place bid button on the GUI over here. So basically what line 437, the string of item name variable, this basically gets the item name from the text field. Over here where this is the string of the bidder name, it's the same thing as this one, but it just gets the bidder name from the text field. And this basically is the variable that we use to associate the bidder name. This line of code, if not auctioncontroller.item exists of the item name, basically checks if the item exists. And if that's not the case, then the item is not found. Else, we parse the bid amount over here, and you can attempt to place a bid over here. And if it's a success, then a bid is placed on that item. And if it's not a success, then the bid fails because the auction is closed or bid amount is too low. So basically the inputs captured is the item name, the bidder's name, the bid amount, and the item validation. Basically call auctioncontroller.exists item name to ensure the item exists. And it calls a place bid method over here, which basically just says if the bid is placed or if it fails. So Now, the button called the place bid method is in the auction controller class, and it is right over here. So basically, this for loop over here, for item, item, and items, basically iterates through the list of items. And if item.getName.equals ignore case of item name, then it returns the item.place bid, basically returning false. So over here, we're basically finding the matching item. And over here, we're basically delegating the bid placement to the item class. And if no items match, then it returns false. So the method iterates through items to find the item with the matching name. So from there, the item class is what handles the bid placement over here. So this method over here basically confirms the new bid amount is higher than the highest bid. So like over here, if not is active or bid.getAmount is less than get highest bid, this basically checks if auction is active and bid is higher than the current highest. Over here, this.bids.pushBid basically add the bid to the list of bids, and it returns true. So the breakdown about this is that it ensures that the auction is active using this method right here. It confirms the new bid amount is higher than the current highest bid. And for bid storage, it adds the new bid to the linked list bid over here. And basically, it returns true if the bid was placed successfully, and false if validation fails. So with updating the UI, once the bid is placed successfully, the user receives confirmation through a J option pane. Additionally, if the Show Active Auction button is clicked, the updated list of auctions with the new bid is displayed with this code right over here. So auction controller.check and end auctions basically ensures the auctions are updated. So with an example run over here, let me add an item real quick. We'll just call it laptop. We'll just say a starting price is 500. The end date can be, let's just say 2024 12.31. And I guess a shipping cost, we'll just say like maybe 60. So this is the item name from the this code right over here, where we get the item name, get the bidder name, and then we check if the auction exists, check if the item exists, my bad. And basically parse the bid amount, attempt to place a bid, and if it's success, it places the bid on it. If not, it fails. So item name is going to be laptop. Bidder name we can call, maybe we'll just call him John. And the bid amount we can maybe say 600. And it places a bid, and the message proves that it was a success. Now, let's just say that we have something like this. This is not a item that the seller has listed for auction. So when we place the bid, this basically says that it was a failure. So if we had something that was not higher than the current amount, like right here, it's basically updated the auction that, hey, John is the higher bidder with 600. If we say that someone else tried to bid, for example, we'll call this person King, and he wants to bid the same amount as this person, it fails because the bid is closed or the bid amount is too low. Now, if we do something like 601, the bid is placed on the laptop and it updates the active auction saying that King is the higher bidder with $601 on the line. And if we go over here where it says refresh my auctions, it basically says that the item is still active, which is what we want to see. So below here is a sequence diagram showing the interaction between the view and controller responsible for placing the bid. When a user places the bid, the auction system GUI class uses the respective event handler to call the respective auction controller function. This function validates the data, creates a bid model, checks the auction status, and returns the result. The GUI then handles this response accordingly, and over here is basically the sequence diagram covering what I just said over here. This is section 3, data persistence. So saving and loading the data. So save data functionality. The GUI integration that we used was a J-file chooser, which is to allow the user to select the save location. The data organization that we use is the data from the controllers, which is the category controller, commission controller, buyer premium controller, item controller, and auction controller, which is organized into a structured format using a string builder. The file writing that we use is file writer, which writes this data into the selected file. The data is grouped into sections for readability. For example, category, seller commission, buyer premium, items, and concluded auctions. So, about the restore data functionality, we decided to skip it because while the saving functionality was a success, we encountered challenges with the restore functionality. Specifically, no data being restored back to the GUI even after the GUI said restore successfully. Another problem that we faced was that even though we got something back, the names nor like the sellers or the auctions that we had that was like not yet expired would not show up on the GUI. So due to these challenges, the restore functionality was skipped. We used AI and other stuff. We researched online and nobody wasn't able to really find nothing. So we just decided to skip it. And the code for the restore data has been commented out, and this is what this is the code for the save all data that we use to save the data to text file. So the J-file chooser basically chooses the file, and we used we use data builders to basically create a good formatted text file for all the controller classes. And for file writing, we use file writer to basically make it look like the way how it looks right over here. And a good sample that I did was this one right here. Basically, we got the categories, the seller commission, the buyer premium, the items, which is listed as true or false, and the ones that are listed as false here are basically under the concluded auctions category. For example, the dictionary. So on this thing, we set the time to December 13th. So all of these were set to false. And a sample run of this, how this can be ran, is right here. So the end date of this is currently 12/31. So what we're going to do real quick is set the time to January 1st, 2025. This basically shows that it is not active anymore. If we save the data over, let's just save it in this one. We'll call it test. And I'll open it up in just a second. This is basically how it would look like. So let me do something real quick. I'm going to add a category and we'll just call it electronics. We'll just put a commission of 10% and a premium of 10%. Now we can save it. Go to 4820. Test, save. Now we can open this again. Open up test. And boom, shows the category as electronics, the seller commission, buyer premium commission, and the item that was listed. And since we set the date to January 1st, 2025, the item is shown as false. And concluded auction, since we had two bids, one was $600, one was $601. The highest person with the highest bid, or I'm sorry, the person who placed the highest bid is the winner. Another way we can see that is by viewing the bid history over here. Basically, the one with the bidder with the highest amount is the winner.
We'll cover time management. So in the system, the time management is handled by the auction controller class. It's responsible for ending auctions and interacting with the items throughout their life cycle. When the system is first initialized, the time setting field in the auction controller object is set to live, and from this point the system can perform two actions on the field. It can get it or set it. Setting the time is done by the set time setting function, which accepts a string. The function is updated through an event handler when the user submits a field in the GUI. Getting the time is handled by the public getCurrentDate function. If the time setting string is live, it returns a local date object. It calls that function now and returns it. Otherwise, it parses the string and uses the built-in local date function to do that. Anytime the auction controller or another class needs to validate an auction, it can call the check and end auctions function, and it compares the current date from the getCurrentDate function against the item's actual end date. And since the time for the entire application is handled inside of these two methods, it allows us to extend the functionality of the program, such as ending auctions automatically. Here you can see that we have an active auction that ends on the 12th. And if we go to the admin panel, I've already entered the data to go ahead and set the current time to the 19th. So if I do that, I can go in here and see that the active auction disappears, and I can refresh my concluded auctions and see that here. I can also set this back to live, and it will not move this back, but the current date is now back to the actual 9th when we're recording. So in the code, in the auction system GUI class, you can see here where we create the panel in that field. And when you submit it, it just goes right to the auction controller class and the set time setting function. So it just takes in a string, sets the field to the string that was given, and up here in the get current date function, whenever anything calls this, it checks to see if it's live, returns now if it is, otherwise it parses the string and returns that. And the check and end auctions function, it gets a list of the active auctions, which is also handled in this class, and then it gets the current date, calls it now from this function up here, and iterates through them, comparing the actual start date or end date, I'm sorry, for the item and the current date.
This is section 5 where we are going to be demoing the GUI code using all the completed user stories. So user story 1 where we have to add a category. So the main code or the main system test that we use for adding the category is this one right here. So basically, this is the system test that I wrote here, where we are getting the category name, where we run the system and we create a category with the name electronics using the constructor and retrieve the name of the category using the get name method. So over here, what we're going to do is that we're going to put a category name electronics, and the category has been added. User story 2 where we are going to be setting the sellers. So what we did was that we coded a commission class for the sellers, and over here the first, I'd say like the main test for this one would be this one right over here, where we are testing the get sellers commission from the controller. So we input a expected commission and oops, and we want the actual commission to be what we expect. So over here we are going to be putting 10%, and the seller commission has been set to 10%. User story 3 where we're going to be setting a buyer premium. Basically it's the same thing as user story 2. Over here, the system test that's the main system test for this one is over here, where we are retrieving the initial buyer premium after creating a buyer premium controller object to ensure it is correctly set during initialization. So it runs the system, creates the buyer premium controller object with the initial premium of 5, and it retrieves the buyer's premium using the get buyer premium method. So this is the code over here where we set the initial, creates a new initial object, we put an expected premium, and the actual premium is going to be the initial one, which is why this test case passed. So over here we're going to set the premium to 5%, and the buyer premium has been set to 5%. So user story 4, we are listing an item where we can list an item for auction. So over here is the system test that I wrote where we are creating an item object using the constructor and verify that all fields are initialized correctly, including the item name, starting price, end date, shipping cost, and active status. So we run the system. We use the items constructor to create a new item with the following attributes. So we can call, for example, test item. We put a starting price, an end date, and a shipping cost. The next direction is to retrieve the values of each field using the corresponding getter methods. All of it is in the item class. And this is the expected output where it shows the name, starting price, end date, shipping cost, and active status. So in our code, or in the GUI I meant, we're going to do exactly that. So we'll say test item. The starting price, I forgot, is 100. So the end date is end of the year, so 2024-12-31. And our shipping costs is 5. We can list it. Item has been listed, and if we refresh my auctions, the item, let's see, we have the item, the price, the end date, and the shipping cost is not on here unless we, yeah, the shipping cost is contained in this because when it later on you will see that in the seller's report that I believe the shipping cost is located there and the active status is true. I'm not sure yet, but I'll see when I get there. So user story 5 where you are showing your auctions. So our description is that it adds multiple items to the auction list using the list items method in the item controller, and then retrieves the sorted list of auctions by end date using the get my auctions method. And what we need to do is verify that the items are correctly sorted from the earliest to latest date. So we run the system, use the list item method in the item controller to add the following items with specific end dates, where item 1, well, we have 3 items in the name item 1, item 2, and item 3. So starting price, end date, shipping costs. So with the test item, we're gonna use it as item 2. We're gonna make 2 more items using these dates, and we will see if the expected output is in the same as what is written here in the system test. So we'll say item 1. We'll refer to this test item as item 2. So the starting price is 20. The end date is going to be January 15, 2025. And the shipping cost is 2. And now we want to add a third item, item 3, where the starting price is going to be 25. I believe the end date was November 15th. Yeah, and then the shipping cost is going to be 4. Now we can retrieve the sorted list of auctions by calling the get my auctions method. So the expected output is that we should have item 3 at the top, we should have item 2 in the middle, and we should have item 1 in the bottom. So oh yeah, I know why this. So what we need to do, well, it's not going to work. So real quick, let's actually change the date to 11-10. We're going to make another item 3, but this time we're going to use the 14th of... No, let's do item 4 and let's do the same thing. So let's do item 4, starting price. We'll just, as long as the date is the 15th of November, we should get the exact same output right here where we have, well, we'll refer to this one as item 3. This is going to be item 2, and this is item 1. And the only thing that matters is the dates. Since we have November 15th at the top, December 31st, January 15th, the expected output from the system test matches the output from the GUI. So user story 6, where we are showing an active auction. So the sixth user story where we are showing active auctions, it retrieves the list of active auctions from the controller and verify that it only includes active auctions sorted by end date in ascending order. So you run the system, initialize the auction controller with the list of items with the following properties over here. It retrieves the list of the active auctions using the auction controller .get active auctions, and the get active auctions method should return a list of active auctions in the following sorted order by the end date. This has actually already been implemented, so what we see here is the expected output basically shows the dates from the earliest to the latest. That's exactly what we have over here. And since one item was inactive because I changed the date, over here, the inactive item is already located in the concluded auction. So basically, it's only showing the active auctions at the moment. So now user story 7, where we are going to bid on an item. So we are going to place a bid on an item and verify that the has bids method returns true. So we are going to run the system, create a new item with the following properties. We don't really need to do that because we already have test item. We're going to place a bid on the item with the following properties. So let's go ahead and put the bidder name. So we're going to do test item. Yeah, we're going to do test item. Test item. The bidder name is Alice, and the bid amount is 120. So basically, the bid was true because it showed that the bid was placed on the item. So over here, this is basically a system test that basically returns the highest bid. So I don't think I wrote this in a better way, but a way how this works is that, for example, we can make another name. We can call it Mary, and we can set its bid amount to 125. So currently, the highest bidder is Alice with an amount of 120. So if we place this bid, this confirms that the has bid method is returning true, and the get highest bid method is basically returning the highest amount that has been placed on the item. So over here, the thing has been updated, and let's say that this person wanted to do the same amount. It's not going to work because the auction is closed or the bid amount is too low. Okay, what's next? This is user story A where you're going to show my bids. So we place a bid on an item and verify that the get current bid method returns the bid placed by the user. So we're going to run the system. This steps is something that we've already done in the previous step, so we're not going to worry about that. Calls the get current bid method on the item, which basically adding the second bid basically confirms it. So user story 9 where we are going to be ending an auction. Basically over here, a system test that we wrote is that we're going to verify the check and end auctions method correctly concludes auctions that have passed end dates. So we're going to run the system, simulate a scenario where today's date is after the end date of some items, call the check and end auctions method in the auction controller, verify the status of the auctions, check that item 3 auction is inactive, and check that item 1 auction is still active. So the date is currently at November 14th. So what we're going to do to basically test this out is let's actually add a bid to item 4 real quick. We'll just basically do this. So over here we're going to refresh my auctions. So this was from the past. So what we're going to do is we're going to set the time to a date that's in between these two days. So let's just say let's do the current day. So actually no, let's do tomorrow. So let's do 2024-12-11 where you're going to set the current date to this, and when we show the active auctions, you notice that one of the auctions is gone. So if we go to the refresh my auctions, basically, since we set the date to December 11th, this item over here is then set to false, while this one remains as true. So if we go to the admin panel and we refresh the concluded auctions, it's shown over here. So basically, this is what confirms our output is correct. So we go to user story 10. Oh, show concluded auctions. This is exactly what I just did. So we ensured that the get concluded auction method retrieves concluded auctions in reverse order. Run the system, call the check and end auctions method on the auction controller to ensure all auctions with past end dates are concluded. So it calls the get concluded auction method in the auction controller, creates a list of expected concluded auctions in the reverse order based on the item list. So the size of the list returns the get concluded auctions should match the expected count of the concluded auctions. So each item in the return list should be match the expected items in the same order. This is exactly what we did right here. So user story 11, where we are going to be showing a seller's report. So we are going to verify that the generated seller's report method correctly generates a report summarizing sales for the seller. So we run the system, we create two item instances with the following properties. We're going to place the bids on both of the items in the auction for both items, add both items to the auction list, and it calls the generated seller's report. So there's the total winning bids, shipping costs, seller's commission, total profit. So the formula that is being for the profit is the winning bids minus the shipping cost minus the seller commission. This is based on these two right over here. And I'll show you an example. So what we need to do is we need to, I believe I had, yeah, so let's currently set the date to 2025, the first day of 2025, since we have an active a bid on this item. So this thing is currently not active. It's been set to false. Refresh the concluded auction. So based on the date from ascending to descending, the ascending one is on top, which shows is that the item return list should match the expected item in the same order. So now we're going to generate a seller's report, and over here we have the test item, we have item 3, and we have item 4. So we add them all up, gets 275. Add all the commission, which equals this. The shipping costs all equals this, and we basically take the winning bid, subtract the shipping costs, and subtract the seller commission, which basically does equal 213 and a half, which basically confirms that this test case, not this one, this test case over here was a success. So now user story 12, where we're going to be showing a buyer's report. So our test case that I wrote was, we want to ensure that the generate buyer's report method correctly generates a report summarizing purchases for a specific buyer. So we run the system. We're going to create two item instances with the following properties, which we don't really need to do. We're going to place the bids on those in the auctions, add both of the items to the auction system's item list. It calls the check-in auctions method, and it calls the generated buyer's report from buyer 1 method on the auction report. So the report should match the following expected format, displaying the buyer premium, the shipping costs, and the amount. So shipping costs is basically adding all the shipping costs, and the buyer premium is what you set on like the third or the second user story. So what we can do here is generate the report. So buyer's premium is added, the shipping costs is added to, and the price of the items is added as well, which basically confirms that this system test successfully runs and matches the correct expected output. So user story 13, where we're going to be showing a bid history. So what we're going to do is place multiple bids on an item and verify that the get bid history method returns the correct bid history order from latest to earliest. So we're going to run the system, create a new item with the following properties. We don't really need to do this. I believe I still have an active auction. And we're going to place two of the two bids on that item, and then we're going to call the get bid history method on the item, which basically the get bid history method should return a list of bids with the following properties. So Bob should be at the top and Alice should be at the bottom. So we have item 1 still active, so we're going to use that. So item 1, we'll say, no, this is just a, we're going to set this to 150. We're going to place that bid, and then we can call the get bid history method on the item. So the way we run that is that we come to the item name, should match the expected, it should match the same item, otherwise it's not gonna be found. So item 1, so the highest bidder is at the top and the person with the lowest bid is at the bottom. So we can do another example. Let's say Alice decides that, hey, I want this item so bad, so I'm going to place a higher bid of 175. We go to the bid history. It shows that Alice is currently in the lead with $175. So now user story 14, where we are going to be setting the date and the time. So we set the system date to a specific custom date for testing purposes and verify that the system date accurately reflects the set date. So we did this, I wrote this system test before the Sprint 1 demo, that's why it's pretty much outdated. But what we're going to do is that we are going to set the system time to, well, currently I have it as January 1st, so let's actually just use this date. So over here, we're going to set the date to November the 5th, and the message says that the current date has been set to November 5th. So if we go over here, let's add an item real quick. So let's do, let's just call it something random. To confirm that this test works, we're going to use the 6th of November. Should have made this a lot simpler, it's fine. Basically over here, basically shows that the time has been set to November the 5th successfully. So user story 15, where we're going to be resuming the real time. So what we're going to do is that we're going to set the system date to a specific custom date and then switch back to the real time mode to ensure the system date resumes to an actual current date. So before I actually do this, I do want to add another item. So I'm actually just going to call it M. Starting price is this, and since the day that I'm recording the video is the 10th, we're going to set the date of this to end on the 11th. So shipping costs is this. So we go to the auction view. Let's just go ahead and just put an auction up for bid. So what we're going to do is set the time to live, which basically sets the date to December the 10th. So over here, we show the active auctions, and this right here where it says 1 day proves that the live feature here sets the date to the 10th. And since the other item was set to expire on the 6th, this item right here, the item is not active anymore, which sets the thing to false, and it's shown here in the concluded auction over here. So I'm gonna talk about user story 16 over, where is it here? Now, something that I did learn, like after I finished coding the method, was that apparently if your code is all into the GUI class, sorry, you cannot write JUnit tests over a GUI class. So I really don't have any tests, any JUnit tests or any system tests that's written, but I'm gonna use this feature to show you what it's supposed to do. And also the video of me demoing this user story is also on the second, not the second, the third part video of the agenda. So let's just call it test 2. Since this is the file that I saved the other one on, I'm just going to use it. So what we expect to see is the categories, the seller commission, buyer premium, concluded auctions, and if an item is active. So let me actually open up the text file real quick. I have to find the folder on my monitor real quick. Okay, there we go. Test 2, we're going to open it into the notepad. And this is our output that you've seen already from a sample that basically shows the category, the seller commission, the buyer premium, the items that I listed for auctions, and the items that have been concluded. So that's that. So user story 18, where we are going to be registering a user. Oh, hold on real quick. The updated system test is in the docs folder in GitHub, so I'm gonna have to pull that up real quick. So I need to go to this docs, this thing. Oh, hold on, I need to remove this. Now let me open this. I need to go to 18. There we go. So the number user story 18, where we are going to be registering a user. So what we're going to do is verify the behavior of the register method when attempting to register a user with a name that hasn't existed. So number one, we're going to run the system. We're going to register a user with the name, and we're going to actually use a different one because for some odd reason this when you run the JUnit test, this automatically saves it into the system, so it'll work the first time, but the second time you do it, no, I'm sorry. Yeah, I was right. So the first time it would work when you set like a random new user, but the second time you do it, the test case will fail. I'll show you an example what I'm talking about. Where is it at? Right here. So I've already ran this code, so what I'm going to be expecting is that this JUnit test case is going to fail. So yep, you can see the icon right here that this test case has failed. So what we're going to do is set a random username. We run the system we run the JUnit test over here, and it's still parsing. And over here, it just shows that it passed. And I guess the only reason why that happened was I use object input stream, and I'm assuming there was something with this that I did because I coded this like I use maps, and I'm assuming something with like this right over here basically automatically saves it the first time into like a file. So when you run this thing again, basically the thing would have already existed. So that's why for some odd reason if you were to run this again, this would fail. So what we're gonna do is demo the GUI. So I'm gonna have to log out of this to demo it. So this is what I'm currently using. So basically, if you wanted to register a user that already exists, the output would just say username already exists. Please choose a different username. So which would prove this one over here. So what we're gonna do is now do a random. We're gonna create a brand new username for over here. We'll just say 12345 6. Basically saying that the user does not exist. Oh wait, that's for the second one. My bad. So we register a brand new user in the name of myself with the first 6 numbers, and our password's 4 digits long. It's basically just 1234, and that basically shows that this right here is working successfully. Now, the last completed user story we did was user story 19, the login user, where we want to verify the behavior that the login method when provided with the correct username and password credentials. So we run a use system, registers a user with a username that, a password that, attempts to log in using the same username and test user, names test user and password is that. We're going to observe the output, and the output should be login successful. So what we're going to do is that we're going to use the default one that I've used, which is my name, the password's 1234. If we log in, the message basically says welcome, and you are redirected back into your system. So the second one that we wrote is that we try to log in with a non-existent username. So let's just put 12. It's a username that has not been registered to the system. So what we do is when we press login, the output user does not exist is what shows up, basically proving that this test case works. So now we want to verify the behavior of the login method when attempting to log in with an incorrect password. So we run the system, register a user with this, attempt to log in with the correct username but the incorrect password, and the output should just be incorrect password. So we'll just put this, and we'll just add an extra password length, and when we press login, it just says incorrect password. And that was the final user story that we was able to code. So I hope you enjoyed the code demo of the GUI, and that's it.